In Latin, Murus means wall or roof. Today, Murus is building the future as the industry leader in sustainable construction using structural insulating panels.
Hello, I'm Steve Keller, founder and CEO of the Murus Company. This video explores how Murus makes structural insulating panels and why not all SIPs are created equally. There are a number of different ways to make SIPs, and Murus has always chosen to use the best processes and materials possible. When I say best processes, I'm talking about a host of issues that creates the best SIPs, including quality control procedures, manufacturing processes and equipment, pre-cutting equipment, the different ways to adhere the outside skins to the foam core center, third-party engineer quality inspections, product testing, material suppliers, and more. And for that matter, there are different foams used for the cores, notably the Murus polyurethane core, and then the variety of polystyrene cores. I want to begin with our polyurethane core SIPs because the manufacturing process is unique and proprietary to Murus. It's called UDM, which stands for Uniform Disbursement Molding. Simply, this process ensures that the liquid polyurethane foam core is uniformly dispersed across the length and width of the SIP. And the importance of this process is to ensure the uniform density of the polyurethane foam for consistent strength and insulating value. Now, there are other companies who inject liquid polyurethane or its chemical cousin, polyisocyanurate foam, but they typically use a lance or a wand to inject the foam, trusting that it will run to the far reaches of the panel, which frankly doesn't work very well and results in voids and inconsistent density, and that means inconsistent R values. Our first stop is the tank room, where we store the raw polyurethane chemicals. These large tanks hold the foam components until we pump it into the day tanks at the point where we inject the liquid foam into the panel mold. We'll see that in a moment. So here you see the mold being ready to make a panel. The bottom OSB skin is secured, the cam locks are mounted on the aluminum rails, and the electric chase is in place. The electric chase is where we run wiring during construction. Notice the profile of the aluminum rails. It creates a tongue and groove interface between SIPs, which automatically aligns the vertical edge of the panels, very convenient for the installer. Other SIPs require a spline or structural framing in place of the cam lock. A note about the cam lock. We designed and patented this in the mid-1980s as an efficient way to join our SIPs. Other cams are metal and subject to corrosion and degradation over time and are poor insulators. Our cam locks are made of recycled ABS plastic, and the tongue is reinforced with fibers that connect to a Lexan receiver pin, all for strength. Understand, please, that the cam lock is only meant to make installation quicker and is not intended to be a structural component. Installing SIPs using our cam lock is more than twice as fast as installing splines and then nailing or screwing them to the panel. Next, the top OSB skin is put into place and it's ready for foam injection. Here we see the foam injection equipment. The foam components are rather finicky and require careful controls with regard to temperature, volume, as well as precise mixing. The mold is run past the foam injection nozzle, where the foam is evenly dispersed across the width of the mold while it is mechanically timed and driven into the opening in the press. After it enters the press, it closes on the raw panel and the polyurethane foam expands while bonding to the OSB skins. The foam generates as much as 14 pounds of pressure per square inch, and hence all the heavy steel framing that you see in the press. All that pressure is a very good thing and ensures the foam expands to form a spherical cell as opposed to foam rising without that pressure, which forms a weaker, elongated oval cell. Very importantly, the spherical cell helps the SIP to uniformly resist load from all directions, whereas the elongated cell, found in most other methods, is less effective in resisting forces uniformly, a subtle but critical feature when analyzing structural loads. The SIP will sit in the press for about 25 minutes until the chemical reaction subsides. At that time, it's removed, stacked, and trimmed, and the cam locks are activated. Trimming the panel is important, because we want an exact panel-to-panel measurement to help avoid the condition where the length of a wall or roof creeps to become a longer dimension, a common problem in the construction industry. At this point, the SIP is ready for either pre-cutting or to be stacked for shipment if pre-cutting isn't needed. So the next stop is the polyurethane pre-cutting equipment. As you may already know, Murus recommends pre-cutting SIPs for most applications. It saves time in the field and eliminates a lot of waste on the job site. We have 2 pre-cutting machines and both are CAD controlled. So our design and drafting department will generate pre-cut drawings based on our client's design. Then with the aid of a couple of operators, the machine does the rest. This is the largest machine of its type in the United States. It is computer controlled and can be operated by one person along with a setup crew. What we do is place the entire roof or wall on the flat bed, and then the gantry comes across the panel, making cuts per the drawings. Then they are numbered according to the drawings and stacked and wrapped for shipment. Next, let's take a look at how we make laminated SIPs. Over the years, I've seen a lot of ways to laminate SIPs. I've even seen Elmer's glue used with a paint roller to spread the glue, and then cinder blocks to weigh down the stack until the glue sets up. Some companies use vacuum bags where the glue is spread onto the skins and/or the foam, stacked up in a big bag, and then the air is vacuumed out. This creates pressure between the layers while the glue cures. Many manufacturers use it because of the low initial equipment costs, but has fewer quality controls. The same glued up SIPs could also be placed in a large mechanical press until the glue cures. I believe the press is a better system than the vacuum bags, primarily because the vacuum bags are not as positive of a system since bowing and skewing of the skins can occur otherwise. Both vacuum bags and the press can be effective processes, but the bags are challenging to maintain the highest standards of quality control. Murus has taken lamination to the state of the art with our custom and proprietary laminator line. Using code-conforming adhesives customized for use with our equipment, we have largely automated production for the purposes of quality control and optimizing output at a competitive price. In other words, with this equipment, we can make a lot of SIPs conforming to the highest standards of quality control in a very short period of time. This is our automated high production laminator. It's capable of making both 4-foot wide and up to 9-foot wide SIPs, otherwise known as jumbos. And it can make SIPs using virtually any preformed foam boards, including expanded polystyrene, neopore, and polyisocyanurate. Again, this equipment makes jumbo SIPs, which have an advantage over smaller SIPs without cam locks. And because preformed foam SIPs can't use cam locks like we have in our polyurethane SIPs, wooden splines, which are nailed or screwed in place, are required, adding to time and labor costs. Consequently, the larger the SIP, the fewer fasteners, although a crane is required to install these larger panels. Let's look at how the laminator works. The OSB skin is picked up and placed on the feed bed and run beneath the glue applicator. This is followed by the foam core being picked up, placed on the rollers, then also run underneath the glue applicator before the top skin is placed on the upper surface of the foam core. Now the raw SIP runs into a press where it stays until the glue cures. When the finished SIP comes out the end, it's ready to either be stacked for shipment or shifted to the pre-cutting station, which we see here in the corner of the building. The PBA pre-cutting machine is moved over the fixed SIP, cutting the exact dimensions for rough openings, roof hips and valleys, and virtually any cut required. When finished, it is labeled for its location in the new structure according to the CAD drawings generated by Murus. Then it's stacked and wrapped for shipment. Our design and engineering staff generates the CAD drawings and a computer program that controls the machine cuts according to our client's design.
The home of the future is being built today with structural insulating panels from Murus.